I'm very happy to take an article, case study article on the topic spectral analysis for computer applications, communication applications. So here specifically I am going to take a signal processing application. For communication speech applications, there is a need to split the voice into the magnitude and phase spectrum. So the need for the industry is a challenging need for the industry to split the voice into a magnitude and a phase spectrum. Once if it is splitted, once if it is differentiated, this is magnitude and this is phase, then it is easy to analyze the spectrum can be analyzed. So you can find the FFT spectrum and other applications using the spectrum analysis. So here any industry will take this as a case study, and there are different applications, technologies used, and here I am going to take an application how to split the voice into a magnitude and phase spectrum. For this I am going to consider a sample, say h of n. My voice sample is 1, 1. This is my voice sample. So here the number of samples will be n is equal to 2. So usually to analyze these voice samples, so this is my voice and I have to convert this voice into magnitude and phase. So for that I use the formula to find the frequency response, where n varies from 0 to 1, h of n e power minus j omega n. Substitute n is equal to 0. So if you substitute n is equal to 0, I will get h of 0 e power 0, then substitute 1, h of 1 e power minus j omega. So what is the special conditions to apply? This condition is, first it should satisfy h of n should be equal to h of n minus 1 minus n. And alpha, the center of symmetry, should be equal to n minus 1 by 2, and the theta of omega should be equal to minus alpha omega. If you satisfy these three conditions, and you can split the magnitude and phase from this voice. So that is the case study. So how to do this? So first I am applying this condition. So find h of 0. h of 0 is equal to h of n is equal to 2 minus 1 minus 0, that is nothing but h of 1. So if I find h of 0 is equal to h of 1. So there is no need to again find h of 1 because both are same. So for these two samples, it is only it is equal to find h of 0 or h of 1. That is the first condition is satisfied. Then find alpha, center of symmetry, n minus 1 by 2. n is 2, 2 minus 1 by 2, that is 1 by 2. Then the third condition is theta of omega. Theta of omega is minus, alpha is 1 by 2 omega. So this is theta of omega. So all the three conditions are satisfied. Then you apply these three conditions into this equation. So first, how to split this? This is a speech signal. This is my speech signal. So I have to apply this condition into this speech such that I am going to differentiate. This is magnitude and phase. So assume that this is the magnitude and I am going to take separately the phase, e power j theta of omega, that is theta of omega. So the remaining will be the magnitude spectrum. So this is my magnitude spectrum and I am taking phase alone separately. So if you take phase alone separately, the remaining will be magnitude. So from this I am going to split the magnitude and phase. So this is the very important case study for industrial applications, particularly for speech applications. So what is theta of omega? Theta of omega is e power j, theta of omega is minus omega by 2. And what is your this h of 0? E power 0 is 1 plus h of 1 e power minus j omega. So I am taking e power minus j omega by 2 outside. So if I take e power minus j omega by 2, what will happen to this equation? So if I take e power minus j omega by 2, and this should be equal to this, so I have to take e power plus j omega by 2. So e power minus j, e power plus j will be nothing but 1, so I will get this equation h of 0. Similarly, here also I have to add e minus 1 plus 1 by 2. So it is nothing but minus 1 by 2. So h of 1 e power minus j omega by 2. And what is h of 0? H of 0 is h of 1. Similarly, h of 1 is equal to h of 0. So I can rewrite this equation as e power minus j omega by 2 into h of 0 is h of 0 e power j omega by 2 plus h of 0 e power minus j omega by 2. And what is h of 0? H of 0 is 1, h of 1 is 1. So I can rewrite this equation as e power j omega by 2 plus e power minus j omega by 2. And what is e power j omega by 2 plus e power minus j omega by 2? This is 2 cos omega by 2. So see how clearly this sample is split into two spectrums. This is magnitude spectrum and this is phase spectrum. So this is the way to split any voice signal into a magnitude and phase spectrum. So once if you know this, you can plot the spectrum, you can find the FFT of this signal, you can find all the applications of this spectral analysis. Thank you.